All right, guys, we're going to continue on with area and perimeter, although this time we're going to actually look to use the calculation and apply it to solve our real world problem. So if you remember earlier this week, I had you sort those task cards. 6 for perimeter, 6 for area. Today we're going to go through 3 perimeter problems, 3 task cards together, and then you'll be doing 3 of the other task cards for your assignment for the day. So taking a look at perimeter. Remember, it's the distance around a 2D shape or figure. So to calculate it, we would be looking to add up all the sides. So again, our operation when we're looking at perimeter is to add. So looking at card K, coach this year has decided to have the football players run a lap around the field for every missed play during practice. The field measurements are shown below. So again, pictures are extremely helpful to help you make sense of the problem. So the measurements are down below, 360 feet by 16 feet is the football. So if we're calculating perimeter, we're going to be adding up all sides. So remember, the missing values, especially when we're looking at a rectangular football field, are mirroring of the other side. So our measurements, 360 is the top and bottom, left and right is 16 feet. So calculating area, again, we're using the operation of addition. And if we grab calculator, 360 plus 360 plus 16 plus 16 is 752. Again, I would encourage you to use your measurements because it is very important. So 752 feet. So stop and think a minute. That is the distance around the football field. And it always helps to look at your answer and remind yourself what it actually represents. Then for the apply question, it's going to be the italicized question on your task card. So in this specific example, it's asking us, let's suppose a player missed 5 plays last practice, meaning that his coach is going to make him run 5 times around the field, right? We want to know how far they've run in total, how many feet. So thinking about our problem big picture, again, reflecting on the answer that we found, 752, that was the distance around one time. 752 feet he just ran. He's got to do it 5 times. So when we are adding up, or when we are looking at doing the same thing 5 times in a row, do you hear me say that keyword times? We would be looking at the operation of multiplying. So 5 times 752, we grab our calculator here, multiply that circle around by 5, we get an answer of 3,760 feet. So that would be the answer to our apply. How far did he run? 3,760 feet around that football field. All right, card G and card F. Those were the other two that we're going to go over that allow us to see how perimeter can help us solve a problem. So letter G, your neighbor wants to put a fence around his yard to keep his 4 little dogs from running away. His property is shown below with the measurement. So let's first start there and we're going to calculate the perimeter. So again, if I think about my problem, I'm putting fencing like that around this guy's yard. So adding up all our values, and again, all of them are labeled. He does not have a perfectly square rectangular yard, so we have 4 different measurements. Absolutely works. Process is still the same, so we're going to go ahead. Oop, I made a mistake there. So we have 13 plus 7 plus 18 plus 14, and you get a total square footage of 52 yards. I apologize. My writing's a little messy there, guys. All right, so then looking to apply it again, I'm going to look for my italicized question. This time it says the cost per yard for chain link fencing is $12.50. So that's per yard. How much can he expect to pay to put up his desired fence? So think, every single yard around his yard is going to be $12.50. He has 52 of those. So again, repeated addition, we're paying $12.50 for every single yard. 12.50 plus 12.50 plus 12.50, right? We could use the operation of multiplication to solve that quickly. So we're going to take $12.50 and multiply it by 52. And you get the answer of $6.50. Now again, looking at what my answers mean, I'm looking at how much does this cost. So it would be nice if you could also show that we are talking about money. So put that dollar sign and add those two decimal values to the right. All right, last application problem. So taking a look at card F. This one was about the YMCA tiling around their new pool. So if we take a look at the picture, you can see the tiling around the outside, and it's clearly perimeter that we need. So calculating our perimeter, this is another problem where you can assume the mirroring sides are the same. So we got 45 feet and 12 feet for our other two measurements. So adding up those values, 45 and 45 plus 12 plus 12. And again, you guys could take the shortcut if you want. Repeated addition, again, is the same as multiplying. Either one of these ways you want to think about it absolutely would get you the same answer, guys. Okay, so we get a final answer. Perimeter is 114 feet around the pool. Okay, so looking at my application question, again, the italicized question. Each tile is 1 square foot, and they come in boxes of 50. So this time we're going to be being asked that how many boxes of 50 do I need to get enough tiles for 114? So this operation, I feel like sometimes is a little bit harder to recognize. You're taking a larger quantity and you're dividing it into boxes. Now I said divide, so hopefully you understand, or hopefully you've picked up that that's the operation we're going to use. If not, it's completely okay to use any method that works for you. If you need to, kind of draw your boxes and say 50, and then here's another 50, that gets me 100. I still would need another box, so I need 50. That's completely okay too. But mathematically, division is the operation where you are taking a larger quantity and dividing it into smaller portions. So we would have 115 divided by 3. Oh, I'm sorry, 115 divided by 50, jumping ahead here. And you're going to get the answer of, so we're dividing it again into boxes of 50, and your answer is going to be 2.28. Now it's important that you take a look again at your answers and see how they answer the question. So 2.28, this describes how many boxes you need. So think, if I asked you to go out and buy me boxes of towel and I said, you know what, grab me 2.28 boxes, you're going to look at me like I'm a little crazy, right? So we need to check our answer for reasonableness. If I need 2.28 boxes, that means I need more than 2. Because again, if we draw pictures to help us understand, here's the first 50. The second box I have is 50. If I put those together, I only have 100 tiles. So I would need to buy a third box in order to have at least 114 tiles. So when you're looking at how much of something you're buying, if it's 2.28, chances are you're going to round up. Again, it depends on what the question is asking, but a lot of time we're going to round up. So our answer, the final answer, is I would need 3 boxes. Because again, I'm applying my answer to solve a problem. Okay, so for your assignments, you're going to complete 3 perimeter problems on your own. Again, you're going to use that middle column. Your worksheet is set up exactly like this. To calculate perimeter here, you're going to see the task card. And then you go ahead and calculate your value of perimeter and then use that italicized question, apply it, and answer the question. So again, you've got 3 problems to try on your own. Good luck.